Hello friends, my name is Vaibhav with my teammate Akash. Today we are presenting our IOT project, which is the gas and smoke detection system using MQ2 sensor. Let's see the components of it.
First we have Arduino Uno board along with the USB cable to connect it with the laptop. Then we have a breadboard for the connections, then a buzzer and MQ2 sensor which detect the gas and smoke. Then we have two resistors of 180 ohms and the two LEDs for the indication and some jumper wires.
The MQ2 sensor which detects the various gases like LPG, methane, propane. It also detects the smoke. When the system is on, it continuously monitoring the air. We set the threshold value to 150. When the gas or smoke level goes up to or above the 150, the LED start blinking and the buzzer start beeping.
Now we are on our computer screen, so let's run the program from the above side, and you can see here the gas values is continuously getting changes by second. Now we see the connections. You can see here a default light is turned on. If we add the smoke in front of the sensor, then it start blinking. It means the threshold value is touched, and the threshold value is 150 for this. Thank you.
Hello all, today we are going to present our mid-sem IoT project, that is Smart Dustbin. So here we are using majorly 4 components. That the first one is Arduino, the second one is ultrasonic sensor, third one is servo motor, that is micro servo, and fourth one is the USB cable and power adapter. So taking a look at components, the first one we are using is ultrasonic sensor. It has majorly 4 pins, that is trigger, echo, VCC and ground. And talking about Arduino, in Arduino we will be using 3 to 4 pins, that is VCC, ground, 7th, 8th and 9th pin. Servo motor is basically a component which is used to rotate a shaft. For example, if we need any rotation in our project, then we will be using the servo motor. And for making the connection, we are using a 5-volt power adapter, which will be directly connected into the power source. Talking about the connections, as she has told, in ultrasonic sensor we have 4 pins: VCC, trigger, echo and ground. VCC of the ultrasonic is connected to the 5-volt of the Arduino Uno. Then ground of the ultrasonic is connected to the ground, in which we have taken the breadboard. As the 5-volt supply, Arduino has only one 5-volt supply. So we have taken the help of breadboard and given the supply through 5-volt through the breadboard to both ultrasonic sensor and servo motor. Then talking about the trigger and echo, trigger is connected to pin 9 of the ultrasonic sensor and echo is connected to pin 8 of the ultrasonic sensor. And now for the connections of servo motor, we have 3 pins over there: brown, red and yellow. Yellow is of ground. It is connected to 7th pin of Arduino Uno. Red is for the VCC. It is connected to the Arduino Uno. Red of the servo motor is connected to the VCC of the breadboard, that is positive connection. And then brown is connected to the of the Arduino. Now seeing the connections here. So let us take a look at the code of the Smart Dustbin project. So we are mainly using 2 functions. One is setup and second one is loop. Setup is for all the initialization of variables and connections which are making to the Arduino and ultrasonic pins. The second one is loop. Loop is mainly used for logic. So the main logic we are using is a calculation of distance. So we are calculating the distance from the time and speed of the sound. So what is the logic behind ultrasonic sensor? It catches the frequency. It catches the frequency of the sound wave, and then it converts into distance. So if that distance is less than 30 centimeters, then that flap of the dustbin will be open. Else it won't go open. So let us take a look at the serial monitor. So 1183 is the connection, that is 11.83 centimeters. So there are 10 centimeters, 14 centimeters. Yeah, that is it.
My name is Vanish Thapa. So today we make our FIOT midterm project. We use a breadboard, two IR sensor, one LED, and one Arduino with USB which is attached with laptop. Next.
So we are using two IR sensor, where IR sensor works like when it spreads the light. When light get reflected, the photo sensor in the IR sensor get the distracted light and send the signal to the Arduino. How it works? Like we made a speedometer by using two IR sensor. When this is the first IR sensor and this is the second IR sensor in the code we have written. So when first IR sensor detects the object in the front of it, it starts the timer, and when second IR sensor detects the object in front of it, moving object, it stops the timer. And here's how it works: when some moving car or something like that passes through it, the timer starts, and then from second IR sensor the timer stops. By this we had the formula that's called speed equals to distance upon the time, which helps to calculate the speed. With help of it, we measure the speed of the moving object. So here we have calculated the speed 66 kilometer per hour, where it is less than 100 kilometer per hour. So here we have the light which glows when it's over speed, like over the 100 kilometer per hour.
So, hello everyone. We develop water quality monitoring system and which include pH sensor and turbidity sensor.
So the existing solutions are there, which helps us to water quality system, which only depends on the turbidity sensor. But sometimes this may happen that water is clear, but it may be alkaline or basic. So it is not portable or not suitable for drinking. So for that purpose, we are combining pH sensor along with the turbidity sensor. So the basic is from the sensor we get the inputs like turbidity and the pH, and with the threshold value we come to know whether the water is safe for drinking or not. This one is the turbidity sensor, pH sensor, and we have connected it all with the Arduino Uno, and further connections will be.
So we have the very simple connection using the jumper wire. The ground is connected to the ground and the VCC is connected to 5 volt. The output of the turbidity is connected to the A0 and the output of the pH is connected to A0 of Arduino.
So here we can see for the clear water and the neutral water, the pH is showing us in the range of 7 to 6.5, and the water is showing it is clear, that the turbidity is below 5. So the water is safe for the drinking. Whether in the another condition for the alkaline water, the pH goes in decreasing way, and it shows it is not safe for drinking. Same applies for the muddy water, which is turbid water. The turbidity of the water increases if we dip the turbidity sensor into the muddy water. That's all. Thank you.